Hi all, welcome to the sixth lecture. In this lecture, we will discuss about the inversions of mechanism. What is an inversion of mechanism? What are the inversions of Fobard mechanism? That all things we will discuss in this lecture. Okay. So first you need to know what is an inversion of a mechanism. From the academic point of view, this is one of the most important things. What is an inversion of a mechanism, or how we can define the inversion of a mechanism? So first I will come back to the definition of the mechanism again. In a kinematic chain, if one of the link is fixed, then it is called as a mechanism. Okay, so in a 4-bar mechanism we have 4 links, so we can get different mechanism by fixing different links. This is inversion. The method of obtaining different mechanism by fixing different links in a kinematic chain is known as inversion of a mechanism. In a 4-bar mechanism, there are 4 different links. So we can obtain 4 different mechanism by fixing the different links at a time, one at a time. This is the inversion of mechanism. The method of obtaining different mechanism by fixing different links in a kinematic chain is known as inversion of a mechanism. See, why we are going to the inversion of a mechanism is that in inversion of a mechanism, the relative motion between the links will not be changed, but the absolute motion will be changed drastically. The absolute motion will be changed drastically. Absolute motion is the one with respect to the fixed link, whereas relative motion is the motion between the various links. The relative motion won't be affected, but the absolute motion will be drastically changed. That is simply saying the output will be drastically changed if we fix each of the links. Okay, see simply see in this thing, AB is the fixed link in this figure. Similar, this is one mechanism. I can obtain another mechanism by fixing AD. If the link AD is fixed, then the absolute motion or then the output motion will be totally different. That is a different mechanism. Similarly, I can fix link CD. So I will get a different mechanism. Similarly, I can fix the link CB. So I will get a different mechanism. So if there are n links, we can get n number of mechanism by fixing several links one at a time. This is basically the inversion of the mechanism, and one point you need to note is that the relative motion won't be affected, but the absolute motion will be drastically altered in this process, in the process of inversion. Okay, so let's come back to the 4-bar chain. This is one of the basic thing. 4-bar mechanism and slider crank mechanism is one of the basic mechanism, not only from the subject point of view, from the academic point of view also. Okay, so this is the basic 4-bar mechanism A, B, C, D, and in this figure AB is the fixed link. The simplest and the basic kinematic chain is a 4-bar chain. It consists of 4 links. Each of them forms a turn pair at A, B, and C. Now let's come to one of the important thing regarding the 4-bar mechanism. One of the important law regarding the 4-bar mechanism, Grashof law. So the Grashof law states that the sum of the shortest and longest link, the sum of the shortest and longest link length should not be greater than the sum of the remaining 2 lengths if there is to be continuous relative motion between the 2 links. That is, I have 4 links AB, BC, CD and DA, like in this figure AB, BC, CD and DA. And if S is the length of the shortest link, L is the length of the longest link, and P and Q are the length of the other intermediate links, then Grashof law states that S plus L should always be less than or equal to P plus Q. Only if this condition is satisfied, then only there will be continuous relative motion between the 2 links. This is Grashof law. So Grashof law states that the sum of the shortest and longest link should not be greater than the sum of the remaining two links if there is to be continuous relative motion between the two links. That is, S plus L should be less than or equal to P plus Q. Only if this condition is satisfied, then only there will be a continuous relative motion between the two links. Okay. So this is the Grashof law. This table I will explain in the later stages. After completing the inversion, I will come back to this table. Then only you will understand what is a crank rocker, what is a double rocker, what is a triple rocker. That all aspects you will understand only after I complete the inversion. So let's start with the inversion of a 4-bar mechanism. Before that, I will come back to the 4-bar mechanism again. A, B, C, D. In this 4-bar chain, one of the links, in particular the shortest link, is normally used as the crank, or crank is the one which makes a complete revolution. And in this figure, AD is the shortest link, and we usually keep the shortest link as the crank, which will make a complete revolution. So here in this figure, AD is the crank, or the one link which makes the complete revolution is known as the crank or the driver. And the link BC actually reciprocates, or simply it oscillates. Okay, it oscillates or it makes a partial rotation. Such a link is called as the lever or the rocker or follower. The one which makes partially rotates or one which oscillates is known as lever or rocker or follower, and the one which connects the crank and the oscillator and the crank and the rocker is called as the connecting rod or simply the coupler. Okay, so in connecting rod, in this figure, AB is the fixed link, AD the shortest one is the crank, BC oscillates or make partial rotation, it is called as the lever or the follower, and the link DC which connects the crank and the oscillator is the connecting rod. Okay, now and the fixed link is the frame of the mechanism. Now let's come to the inversion of the 4-bar mechanism. From the academic point of view, we need to study the various inversions of the 4-bar mechanism as well as the inversions of the slider crank mechanism. So let's first start with the inversion of the 4-bar mechanism. There are 3 inversions of 4-bar mechanism. Beam engine, the one already we studied, other 3 are the beam engine, double crank mechanism and double lever mechanism. Okay, so let's start with the crank and lever mechanism, or simply the beam engine. I think the animation will be enough to explain this figure. Animation is more than enough to explain this figure. So this is basically the beam engine or the crank and the lever mechanism. There is a crank, there is a lever, it will be connected to the flower. Okay, so when you look at this figure, you can see the fixed link 1, AB the shortest one which is the crank, and the and CDE, this one CDE, this is the lever, and BC which connects the crank and the lever is the connecting rod. Okay, so there are 4 links, link 1, link 2, link 3 and link 4. Some of you may confuse that CDE is one link and this piston rod is another link. It is not like that, because the CDE is actually the link. The piston rod doesn't make a relative motion with respect to CDE. So the piston rod is not an extra link. So there are only 4 links. One is the frame, the crank, connecting rod and the lever. The piston rod is actually not a link because it does not make a relative motion with the other links. Okay, so this is the beam engine, crank and lever mechanism. The animation is more than enough to explain this one, and this beam engine is used for converting the rotary motion to reciprocatory motion. Okay, the rotary motion of the crank is converted to reciprocating motion of the piston rod inside the cylinder through this beam engine. Okay, so the next inversion is the coupling rod of a locomotive or double crank mechanism. Here it is called as the double crank mechanism because there are 2 cranks. That is why it is called as the double crank mechanism. The animation again is self-explanatory. You can identify the motion of the various links through this animation. Again, in this mechanism, AD and BC are the cranks. That is why there are two cranks, and that is why it is called as the double crank mechanism. Okay, and there is a fixed link AB, and it is connected to the wheels. It is connected to the wheels by the link 3. So, this is the coupling rod of a locomotive or a double crank mechanism. It is called as a double crank mechanism because it has two cranks. Okay, the CD act as the coupling rod or the connecting rod, AD and CB is the crank, and AB is the fixed link. Okay, so this is the one thing. See, where this thing is used is that this mechanism is mainly used for transforming or transmitting the rotary motion from one wheel to the another. One wheel to the other, for transmitting the rotary motion from one wheel to the other. Okay. So, this is the basic function of the double crank mechanism, transmitting rotary motion from one wheel to the another. And the last mechanism is Watt's indicator mechanism. This video will explain this thing. Yeah, this video is more than enough to explain the double lever mechanism. Again, you just look at the video. So, this is the thing. Okay. So, if you look at this figure, in this figure, A is the fixed link. A is the fixed link, and the other three links are, one is the link AC. Link AC is one link, link CE is other link, and link BFD is the fourth link. BFD is actually a single link, that is this one. This one is actually a single link because there is no relative motion between them. So, it is called a, so it is a single link. Okay. So, in this case, the link CE and BFD act as the lever. Okay. So, this is the double lever mechanism because there are two levers. One is the link BFD and other is the link CE. These act as the lever. Okay. So, this is the double crank mechanism. Okay. These are the inversions of a 4-bar mechanism. In the next lecture, we will discuss about the various inversions of a slider crank mechanism. So, what you need to know is, if from the academic point of view, if this is asked in the university question paper, then first you need to draw the figure, then explain what are all the 4 links, and finally explain which motion is converted to which motion, or what is the basic purpose of this mechanism. Like if we took this first one, beam engine, you need to draw this figure, then you need to name all the different links, and finally what is the function of this mechanism. The basic function of this mechanism is to convert the rotary motion to reciprocating motion. Same is the case here also. It is called as double crank mechanism because there are two cranks, and the basic function is to transmit the rotary motion from one wheel to another. You need to mention what are the various links, that is which one is the frame, which one is the crank, which one is the connecting rod, and which one is the oscillator. Okay. And the last one, the double lever mechanism. Here there are two levers. You need to mention which is the frame, connecting rod, levers and all, and finally which motion is converted to which motion. Okay. So, this is the inversion of a 4-bar mechanism. In the next lecture, we will discuss about the inversion of slider crank mechanism. Thank you for listening. I am Vipin Goban signing off. Thank you.